So, we're getting closer and closer to learning how to really factor. But today, we're going to be actually getting sort of into when you do the complex trinomials, you have to know how to do this skill here, and that is determining the binomial factors, and that's by taking out a common factor. Now, this really helped the last class, the students that were having trouble. But when you have, say, 3x squared y plus 6x cubed y. Okay, what's common in both of those that I can take out? 3x squared y, correct? And this would leave me with 1 plus 2x. Yeah, you divide it out, right? Now, do you see how in both terms 3x squared y was common? Here is like two terms. Now what is common? What do both of them have? An x minus 3. So let's take that out, x minus 3. What would they be left with? 7x plus 4. Okay, so now it's like, if they both have an x minus 3, you can take it out, if it's in brackets like that. The next one, do you see which each one of them has? That each has a b plus c plus d. So if I take that out of each one, I will have a minus 2a minus 5a. Can't you just get those all together? They're all right terms. That's b plus c plus d, all multiplied by negative 6a. Okay, so let's look at these. So we got like two terms. Yeah, I know what you're thinking. You're like, but this is two terms inside of two terms, okay? Well, this is considered like one unit. So I can take that one unit and put it out front. I'm going to take out an a plus 9 on both of them, which would leave me with 2a minus 3. What about the next one? Take out a, and that would leave me with 3x minus 7. Next one, take out a b plus c, and that would leave me with 21d. No, you got to look at this as one thing. Taking that one thing out front. Because if I was to multiply this thing back in, do you see how I would get back to my original? Okay, this one we're not done. Why? Everyone's like, oh yeah. Well, why? You can still take out a 7. So this would be b plus c. You can also take out a 7. leaving you with A plus D. See, taking out the B plus C is the same thing as taking out the 7. Because B plus C is a unit. They have brackets together. Yes. Sometimes when I get thinking about the next thing I'm going to say, I don't do a good job on what I'm supposed to. Yeah? I would have to factor it in to be 7B plus 7C, right? That 7 came out, just like B plus C came out. So the way you would write this is, if you want to finish it off, just like that. But they're all multiplied to each other. And if you want to take the time to multiply them all out again, you will get our question. It could, and which it would still mathematically be the same. Yeah. See, when you factor things out, that's the only time you really know if they are all the same. Okay. Now, what we're talking about is grouping. Now, a type of common factoring used in polynomials with 4 terms. You see what all the rest had? 4 terms, where one GCF can be found for 2 terms, and another GCF for another 2 terms. The goal is to get the same thing in both sets of brackets. And then we can do what we just did on the last page. Okay? So here's what you do. This is a really good skill to learn because you're going to be using it a lot. So I want to look at, let's take these two and then these two. Now look at that first set. Is there anything I can take out? Be greedy. 2A, leaving me with C plus B. Okay, anything I can take out of that second one? 3B. Yep, 3B. Anything I take out of that second one? 5B, which would leave positive 5B, correct? Which would leave me with C plus 3B. Now, what do we notice? So it looks like the last page. We can take out a C plus 3B, leaving me with 2A plus 5B. Now, if this was the question, how would I get to here? Foil it. Does everyone remember to foil it? You'd go C times 2A to get 2AC, and C times 5B to get 5BC. Okay? You'd get them all. So, do you see what we're doing right now? We are doing what I would say is we're now doing reverse foiling. Okay, we're going 100% backwards. And the way that you would find out if your answer is correct is foil it. Okay, so this is a much, much, much higher level of learning. To go reverse foil is a lot more difficult. Okay? So, in the first group, what can you take out? Leaving me with? Okay. Second group, leaving you with. So you would be finished at this point if these weren't the same, right? Couldn't go on, but because you can go on, we're gonna. So what can you take out? a plus x, and more importantly, what are we leaving behind? A plus y. And again, if you want to FOIL it, you will get back to the original question. Okay. Let's go next one. So with this group, I would take out a 6mn, which would leave me with no, because I'm taking out a 6. M plus 2m. N. Sorry. Okay, in the second group, you always have to take something out. Take out a 1, right? 2n plus m. Do I have the same thing? Yes, I do. That would be take out the m plus 2n, and you will be left with 6mn plus 1. Say that again. Okay, so help me out. With this you're talking about, you would have Well, you're not combining these because this is multiplied to this, and this is multiplied to this. So you can't go and combine them. Okay. So summary of the steps of how to do these. So you want to, first of all, group the first two and last two separately. And 2 is find the GCF and factor it out. Then 3 would be factor out identical factors from step 2. So factoring out factors sounds weird, but those factors that we got, pull them out. Okay, let's keep on doing these. Try this one here, okay? So in the first group, what can we take out? That's it, leaving me with 7x plus 2y. Now, if I take out a 5, which you can. Oh, I didn't. That's an x. That's why you're giving me the dirty looks. I thought maybe you just didn't understand. I'm like, okay, cool. Let her work it out. Okay. Now, if I took out a 5, would that look the same inside the brackets? No, so then I can't do my next step. So you want to take out a negative 5. And I know it's, the students, they ask right away, like, how do you know? How do you know? Why didn't I would have just taken out a 5, right? You know how I know? It's because I know where I'm going, and I would like those to be identical. So I want them to be identical, so I will take out a negative, not a positive. Okay? So you kind of have to know where you're going to be able to say which one you're going to take out. So if I take out a negative 5, that would give me 7x plus 2y, right? Because a negative divided by a negative is a positive. Okay. And now I can factor out my factors. So 7x plus 2y comes out, leaving me with x minus 5. Okay, these next two, not for the weak. Okay, not for the weak. How would you do B? I'm not even going to help you guys. You have to tell me. Anyone have any suggestions what to start this? Yeah? If you did, you could. But that actually is going to make it too many terms. Because this only works with 4 terms. Yeah? You can never do that, remember? But you're close. Yeah? Yeah, so if you write this as m plus n times m plus n plus 5m plus 5n. So if you look at this as like 1, and this is the other, so this one's kind of already factored, right? M plus n times m plus n. But is there something I can take out of that second set? Take out a 5, positive 5, and that would leave you with m plus n. Now, does each of them have one thing in common? They both have a m plus n. So if you pulled an m plus n out front, in that first set, what would be left? No, first set, m plus n, right, plus 5. So I guess I want you to picture these two groups are the same, correct? So I divided them out. And these two are it's kind of like, this is like a coefficient. So what was I left with? I was left with m plus n plus 5. Okay? So that one's kind of weird. How about C? Okay, why? Why don't you like it the way it is? Okay, but was A like terms?
Well, they had something common.
Okay. Do these two have something in common?
No.
Yeah.
3.
Okay. But it's like Matt is kind of right in that if we would move a couple things, they'd have so much more in common. Like if these two switched, well, I guess here's the, let's just do it like it's set up. Because if you did this and this, you could take out what? A 3, and that'd be like a squared plus 2b squared. No, because they each have to have that. If I'm pulling something out, if I'm dividing something out, they both have to have it. Then the next one, I could pull out an A. And that would leave me with negative 9 minus 2b squared. And that's not fun. Can't even do the next step. But what if you just took these two and traded them? And you'd have 3a squared minus 9a plus 6b squared minus 2ab squared. And then I'm going to do, all I did was switch these two. I haven't done any math. I just switched them. So if we do that, then I do this. I can take out a 3a, leaving me with a minus 3. If I take out the second set, so let's say I took out a 2b, that would be can I just take out a b? B squared, exactly. So that would be 3 minus a. I divided 2 out. 2 is a common factor. 6 and 2 is 2. Yes, they're not the same. But, you got a question or an answer? 6b squared. Okay? Yeah. They don't, because that's a minus 3 and 3 minus a. So they won't. What if I would have taken out a negative 2b, then that would be negative 3 plus a. Now is negative 3 plus a the same thing as a minus 3? Yep. Again, people, I know I've been in your spot. You're like, what? Like, how do you know to do that? You know to do that because, oh, I can't go on. Like, I can't do that step, so I will go back and do this. When you get good enough at these things, you learn to kind of be thinking ahead a little bit. So we take a minus 3, and that would leave me with 3a minus 2b squared. Okay, so that's why those ones are a bit tricky, but now that you've seen them. Yeah, it's just weird to have it that way. Okay. Now this one's just one of those word problems, right? So Sandra's an event planner, and she's organizing her first event. She has 3 types of party decorations. So let's just circle the types. We got 16 banners, 20 balloons, and 28 rolls of streamers. And don't worry about the prices right now, because we can figure out that later. What she wants to do is she wants to make piles, okay? And all piles have to be equal, because she's going to distribute them. So if they all have to be equal, what are some options? 6 piles? What did you say? 4 piles? Okay, could you have 1 pile? Yes, you could. Okay, so, or 1 group. So she wants to group, right? So well, let's call them a pile, because it'd be like 1 pile would have 16, 20, and 28. Obviously, those will be distributed equally because you've only done 1. Now, what's another option? 2 piles, right? And in each pile, there would be 8, 10, and 14. Or you could have 4 piles. And if there's 4 piles, 4 and 7. Could you have any more piles than that? Now, you may not realize this, But okay, that's if there's one pile. That's if there's two piles. And that's if there is four piles. And they always tell you at the bottom. So that's our GCF chart again. Okay? So how many in each group? We got it right there. And then how much money would each group be worth? Well, we don't have to do all of them. Let's just do for 4 piles because we'll get the gist. So that's 4 times a banner's worth $12. And then what do we got? 5 balloons. And they're $2 each. It's an expensive balloon. Just thought about that. And then we also have streamers, 5 of them. No, 7 of them, sorry. At $1 each. So 4 times 12 is 48, plus 10 is 58, plus 7 equals $65. Okay, so each pile would be worth $65, right? And at the end of the day, I think if you had 65 times 4, that should equal 2 times what money you get there, right? Or one group of just all this stuff put in. Okay, so it's a pretty nice day today. There's the homework in the book, and then there's the worksheet that I gave you. So we should be able to all finish. Yeah, I know. It's almost too much time. You guys are going to be out stealing cars and stuff and burning places down. Empty hands are the devil's workshop.